So now let's talk about transportation networks, because anytime you have a freight transportation system or a passenger transportation system, it actually is comprised of multiple networks that are usually layered. So let's talk about this through an example. This is a slightly different example. This is for a chemical manufacturer that is shipping products from the east coast of the United States to Rotterdam in Europe. So what I've got is two plants, one here in Bristol and one here down in Ashland. And what they are doing is moving product in tank cars to different ports and then on to Rotterdam. So they have different options, and that's what this picture is showing. The white arcs are trucking. So I could truck from this plant down here in Ashland to straight to the port in Savannah, or I could do a drayage move to a rail yard in Atlanta, and then they would rail it down to Charleston or to Savannah. And similarly, up here at the Bristol plant, I've got some options too. I can rail it directly to Newport News, Virginia Beach, the port up there, or down here to Charleston. At each of those ports, I've got different options for different strings from ocean carriers, just like we talked about in the previous video. So this is what it looks like in the physical sense, and when I make decisions between a truck, a carrier, a rail, or ocean. But let's look at it in slightly different terms, and that's in terms of the networks. The lowest level of network is what's known as the physical network, and this is how the product physically moves. So what I'm showing here, for example, from this Bristol plant to the port of Newport News, it's going to go on the rail, and this is the actual path it takes, that the rail takes. Same thing with the path down here to the port of Charleston. Same thing with the different trucking options, the highways that it would take. So that's the actual physical movement or the physical path on the ground that the product would move. Now, sometimes we want to think about the operational network. The operational network is a series of nodes and arcs. A node is where I can make a decision point. For example, at this plant, I'm deciding whether to go to this port or down here to this port, down to Charleston. So every node is a decision, and the arcs are those decisions that are made. So here at the port of Charleston, if I go that way, I have to decide between these different options for ocean carriers. So it's more like a decision network. Then the third network that's out there is known as a strategic or service network. And this is more of a path from end to end, from the very beginning, from each plant to the very final destination in Rotterdam. And so all the different routes and nodes and arcs that comprise one path are now summarized into one of the individual paths. So what I can do is I can get rid of now the actual map, because all I really care about are these different levels of networks. So again, the physical network is the actual path that the product moves, and this is the basis for all cost and distances. Whenever we want to know a distance between, say, Boston and Atlanta, I can look that up on a map or use some kind of service. It's typically found once and then updated, right? Because it doesn't change that often. New highways don't suddenly appear. But if they do, then that's where you need to update this physical network, because this is where we take the raw calculations, cost and distance. They feed into the operational network, where I make decisions from nodes and arcs. So every node is a decision. So you can think of this as a node and arc kind of network. The final network is the strategic or service network, and this is what's known as a path. So it's a path representation where each possible flow from origin to destination is now comprised into one arc. And so why do I have these different paths here or different networks? Well, it's because different people use different representations. If I'm a planner, I'm going to use this strategic network because I've got to decide overall which path to do. This will give me, all I care about is the cost and maybe the time. And so this path representation really fits my needs. If I'm a carrier, I'm probably operating in the operational network because I need to make a decision at each of these nodes. I want to set up my network so I have options. And then if I'm executing, I'm actually in the physical network because I'm actually there on the ground. Now, there are other networks that are available, especially if you're a carrier. You can think if you have crew or drivers to schedule, they will move in a certain network. You can think of the vehicles themselves, how they get redistributed back. They operate in a different network as well. But we're going to focus on just these three: the physical, the operational, and the strategic. So let me talk about them just really quickly. The physical network consists of guideways and terminals, nodes and arcs, right? So the guideways, they can either be free, think of the air, ocean, rivers. They can be built with public or government funds, roads, typically in the U.S., privately built, railroads and pipelines, again in the U.S., they're private. However, this differs by country. Some railroads are publicly built with government funds or owned by the government, and vice versa. So every country is a little bit different. The terminals, again, they can either be publicly or privately built, and you can think of airports, seaports, trucking terminals, rail yards. So there's all series of different types of terminals, but generally what happens there, it's a transfer from one mode to another or from one vehicle to another. And then the last thing that kind of ties it all together is how is the operation controlled? Generally, if it's using some kind of shared public space, the government is involved in some way, whether it's an air administration or administration of rules of the highway versus if it's done privately. And so the physical network is important, and it's the primary differentiator between when you're doing freight decisions in an established network or something that's more remote. If you're in an area where the roads don't exist, the physical infrastructure is constantly changing, then this physical network is very important. If you're in a more established network, it's an input, it's a given, and you use this to make decisions. So let's go to the operational network. Now, the operational network, what's interesting is it ties together the four key components of any transportation system. And that is, one, the loading and unloading of equipment, of vehicles, or of materials into and out of a vehicle. This process known as local routing or vehicle routing, where you're doing local stop-off and delivery. A line haul, which is kind of that direct mode that we talked about earlier, where I pick up in one location and deliver in another single location. And then sorting, where I might bring stuff into a facility and some things that are in one truck, I split them up and they're going to be sent in separate trucks going forward or separate vehicles. So think about when you fly anywhere in an airport, you load and unload yourself onto the plane. When you get to a terminal and you have a connection, you self-sort from one gate, you walk to the other gate, and then once you're on the plane, it's a line haul moving from one point to another point. So the same thing happens in freight. So I might have a bunch of collection of materials at one point, and then I will have what's known as local routing or vehicle routing, right? To pick up, it's a pick up, pick up, pick up. This is also known as a pickup cycle. The product then comes to this facility. This is a local sort facility. So I might take some of the product that's destined for another location and send it somewhere else, but I'm going to sort them into different areas, and this one is going to go in a line haul move from this local sort to this hub, and that's called a line haul move because it's going from one origin to one destination. And at that hub, I might move it on a direct line haul to this location, or what I show here is a direct line haul to this hub. So you have a series of line hauls, and then I get down to its final destination, and I might have a sort there, put it into a local truck, and deliver it out. Now, this is the same thing that's used for air transportation. You can think of buses doing the same thing, where a bus will come and pick you up, and then might take you to a terminal to another bus that goes directly to another station. It's the same thing as for trucking, as well as other modes. This is a node and arc view. At each node, I have a decision of what I want to do next. Okay, the next network is the one that for planning purposes we're going to spend a lot of time on. And this is the path view. So when we're talking about shipping our shoes from Shenzhen to Kansas City, what I've got here is different options. And I've just summarized three of them. One is I could do air, and I haven't talked too much about this. It takes 3 days because it takes a little bit of time to get it there and clear customs and things. And it's about $1.50 per pair of shoes. I could do that all-water route through the Panama Canal and into the East Coast, and that takes a lot longer, 10 times longer, but it costs a lot less, 65 cents. Or I might want to be able to do something in the middle where I come in on the West Coast, that land bridge option we talked about. It takes about 28 days and 75 cents per pair. So this option, this view, this path network allows me to make choices, because we know from looking at inventory that if I know the lead time, right, and I know the cost, this is just an additional cost, a V or a C, right, the cost per item, variable cost, then I can make decisions, and this will influence my inventory decisions. So we've gone through the physical network, the operational network, and the strategic network. When we talk about inventory planning and how it fits to the larger system, we're going to focus in on the service network. So let's do this next using the example.